Okay, so we are trying to find roots, and we want to write them as fractional exponents. So this says the square root of 8. That means 8 to the 1/2. When you have a root, your root is the denominator of the fraction. Okay? So if I give you the cubic root of 15, then that would be 15 to the what power? Exactly. And if I give you the fifth root of 32, that would be 32 to the... Okay. Now on this one, notice the negative sign. It's not inside with the root, it's outside, correct? So the negative sign is not part of your being raised to a power. So I'm going to write this as negative parentheses. Now, what exponent am I going to write on the 4 if I have it as the square root? 1/2. Right. If you can simplify these down, you would. This would simplify down to 2. The fifth root of 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. You can do it in your head. The fifth root means I need a number appearing 5 times. 1, 2, 3, 4, 5. The 2 appears 5 times, so the fifth root of 32 is just 2. Yep. Because the square root of 4 is 2, but it's negative 2. There's no I associated with that one because that negative isn't underneath the square root. That is not plus and minus because I'm not creating an equation. Do you understand that? In parentheses, 1/3. Okay, so the denominator is the root. The numerator is the exponent. So a fraction has a numerator and a denominator, right? So the top number is your exponent, 2 to the 3rd. Your denominator will be the square root or the cubic root or the 4th root. So when I look at 6 to the 3/2, this is my exponent and this is my root. And so you can think about it as the square root of 6 to the 3rd. Yep. So that's the square root of 6 times 6 times 6. And if I had to simplify that out, it would be 6 square root of 6, wouldn't it? If I had to simplify it out. Square root means my number appears 2 times. You with me? Okay. Okay, the 16 to the 4th power. So my exponent is 1, and my root is 4. So this is the 4th root of 16. Well, 2, 8, 2, 4, 2, 2. How many times does the 2 need to appear before I can pull it out? 4 times. How many times is it appearing? So what is the 4th root of 16? 2. Right. I can pull out, I have the 2 appearing 1, 2, 3, 4 times. So the 4th root of 16 is 2. Likewise, if I wanted to check myself, I'd take 2 and raise it to the 4th power. And what should I get? Exactly. Good? Okay. Negative exponent. Can't deal with negative exponents. So we flip it. So if it's 16 to the negative 1/4, then that's 1 over 16 to the positive 1/4, right? Your exponent goes from a negative in the numerator to a positive in the denominator. I thought the negative 1/4 was my exponent, and it exists on my 16. Right? I mean, if I gave you s to the negative 1, you wouldn't leave that s on the top and put negative 1 down below, would you? No. You would say, oh, well, that's 1 over s to the positive 1. What's your base? Your base is 16. It's got to go from the numerator where my exponent is negative to my denominator where the exponent will be positive. Now we work it the way we did before. This is 1 over the 4th root of 16, which is 1/2. And we know it's 1/2 because we know from the previous problem that the 4th root of 16 was 2. Very different. Okay, here we go. The 2 is my, and the 3 is my root. So the 8 is going to be what? And then, right. And it really makes no difference which way I do it. I can do square my 8 and then take the cubic root, or I can take the cubic root and then square it. The order in which you do your power and your root doesn't matter. I feel if I can make it smaller before I make it bigger, it's easier to do. So do I want to square the 8 and then take the cubic root, or would I perhaps, do I know what the cubic root of 8 is? Nope. Nope, they won't. What's the cubic root of 8? And what am I doing with that 2? Right. So this is 2 squared, which is 4. And the cubic root of 64, guess what? It's 4 also, because it's 4 times 4 times 4. So you will get the same answer either way. If you square it and then take the root, or if you take the root and then square it. Okay. Are we good? Okay. 8 to the negative 2/3. My base is 8. My exponent is negative. Before I think about what I'm doing, I have to make my exponent positive. So I got to drop it down below, the whole thing. Correct? And then I go through the same process. I say, well, that's 1 over the cubic root of 8 squared, which we know that cubic root of 8 squared is 4, so this is going to simplify to 1/4. Okay, so this is where do you know your rules for your powers? If you don't, this will mess you up. So raising powers, 2 powers. What do we do with those numbers? So this is 2 to the negative 1/3. Would you agree? And this is x to the what? Negative 3/3, right, which is negative. Nothing can we simplify, especially a number, with a negative exponent. So where does the 2 to the negative 1/3 go? On the bottom. And where does the x to the negative 1 go? And so this is x over 8. Yep. This is just some more power rules. Okay, somehow this dropped out. This is negative 2/3. Do you have that fraction line? Did you? I had to put this in. For some reason it dropped as it transferred. Yeah. If you have it in Word document, it's probably okay. Just sometimes when it transfers to Smart, it drops. Okay. So what are we going to do with that exponent? So x to the, okay, careful. 2 to the 6, x to the negative 4th. Because we're multiplying negative 2/3 and 6, which will be negative 4. Anything with a negative exponent needs to change places. So that means this x to the 4th can really go to the top. So that's x squared x4. 2 to the 6 is 64. So that's x to the what? Over? Yep. We said 2 to the 6 was 64. Better? Okay. All right, next one. Is this a distribution problem? What do you look for if you need to distribute? Parentheses with what? This is not a distribution problem. That's not distribution. I need adding and subtracting in one of my parentheses for there to be distribution. This is purely a multiplication problem. I'm multiplying everything, so we're going to reorganize. Right, this is not a distribution. But I'm not raising powers to powers. I'm going to reorganize this, Abby. I'm going to put the numbers together, and I'm going to put the variables together. No, I'm just because it's all multiplication. So it's all one multiplication problem. So 2 times 4 is? And an x to the 3 halves and an x to the negative 1 half. What do we do with those exponents? So what's 3 halves minus 1 half? 2 halves, which is, right. But if you don't know your rules, you will mess this up. If you are not confident, do I add, subtract? Do I multiply? Is this a distribution problem? This will mess you up. All right, here we go. Solve or simplify the following equations and round the answers to 2 decimals when appropriate. Okay. I want to solve for x. Sure. Because 3 halves minus 1 halves equals 2 halves. Right? So you got to know how to add and subtract fractions now. All right, x to the third equals 64. I need to solve for x. If I had given you x squared equals 64, what would you do to both sides? So if I'm going to have x cubed equals 64, what do I need to do? Cubic root it. So x is equal to. Now, this is not a plus and minus answer because the cubic root is either negative or positive. Square roots can be positive and negatives because when you square a negative, you get a positive, and when you square a positive, you get a positive. But if you cube a negative, you only get a negative answer. Yeah. And you can take the cubic root of a negative number. No, there's no i's with cubic roots because the cubic root of negative 8, well, remember, I'm supposed to be able to create that value 3 times. And isn't that negative 2 times negative 2 times negative 2? Isn't that equal to negative 8? So well, what's 2 times 2 times 2? No, because the value has to appear the same every time. So that's why cubic roots give you only one answer, either positive or negative. Odd roots are that way. Plus or minus, right.
So if it was like to the 6 or something, it would be a plus or minus?
Okay. All right, so what is the cubic root of 64? Yeah. That's why you need to know some of those cubic roots, at least to 5 to the 3rd power. Okay, So you're going to want to isolate the term that's got the exponent, which means in this next problem, what do I move? Multiply by 2's because we have to get rid of the 1/2. So that's x to the 5th is equal to 1024. So what do I do to both sides? 5th root. X is equal to, well, that's 2 times 512, which is 2 times 256, which is 2 times 128, which is 2 times, okay, which is 2 times, and 2 times, and 2 times 8, and 2 times 4, and 2 times 2. I need them in groups of how many? 1, 2, 3, 4, 5. I can take out A2. 1, 2, 3, 4, 5. I have another 2 that I can take out. So my answer is 4. Did you follow that? If you want to get the right answer. It won't always come out pretty. So I took out one set of 2's, and then I had 5 more, so I could take out another set of 2's. Okay, if I'm trying to isolate, what do I need to move? This 2, right? How do I do it? X plus 2 cubed equals negative 7. Can I distribute that cubed into my parenthesis? I would have to FOIL it. Do I want? I got a cube rooted. Do not distribute this exponent. We never distribute exponents into something that's adding and subtracting. Don't tell me that that's x cubed plus 2 to the 3rd. That's a big algebraic no-no. Okay? So yeah, we take the cubic root. So that's going to be x plus 2 equals the cubic root of negative 7. And what do I do now? So x is equal to negative 2 plus the cubic root of negative 7. So the directions say round your answer to 2 decimals when appropriate. This would be inappropriate. So plug into your calculator negative 2. And let me show you how you find your cubic root. So I'm going to hit negative 2 plus, go to, I think it's under math. There's math. Now look, this 4, that's cubic root, right? If I want something other than the cubic root, I'm going to use number 5. I just have to type that number in first. Like if I want the 5th root, then I go 5, and then I hit this right here. So we want 4, and then we want negative 7. Close my parenthesis, and I hit. So I get negative 3. What it says, round to the nearest who? Hold on. Equals, so that's negative 3.91. Yeah, just take this. You're good? Okay, perfect. Yes?
Can we do the very first
Of what? The whole problem is to isolate, so that 2's got to come over here, and we do that by subtracting. So negative 5 minus 2 was negative 7.
You're going to get rid of the x plus 2 cubed, you just cubic root it and
Right.
by itself.
Right? Because we learned how to do it in the last chapter that we take the square root, right? Okay. All right. Last one. So I have 1 over. Do I need to bring this part of my term up to the numerator? Why not? Correct. The exponent is not negative, so who cares? So that's saying 1 over negative 15. What am I going to do with that value? Huh? To the 3rd. And it's the, what kind of root? Fifth root. Are you with me? You with me? Okay. So on my calculator, I'm going to take negative 15, and I'm going to do what to it? So I'm going to raise it to the third power, right? And then I'm going to take the fifth root of that. Would you agree? So I'm going to hit 5. Yep. And then I'm going to go to my math button, and I'm going to hit the number 5 because that's my root. And then I'm going to type in. Now, do you know how to just plug in that answer without having to type in? Second answer. And then I'm going to hit enter. Now, is that my answer? That's one. I need to do 1 over that, right? And so look at this handy dandy key. Isn't x to the negative 1 1 over? So I'm going to take my answer, and I'm going to make it negative because I'm going to flip it, right? So my answer is this.
Wait, what did you just had to, why did we have to flip it?
Because it's 1 over that stuff that we were plugging into our calculator.
So why don't we just bring the negative 5 up to the top if that was supposed to be in the denominator?
Why would you bring it up to the top?
Because it's negative.
What's negative? The exponent or the value?
The value.
Who cares if the value is negative? The exponent.
Keep it 1 over negative 5.
Well, what we plugged in, Meg, was negative 15 to the third, and then I took the fifth root of that, and I got negative 5.077. So what I really have is 1 over negative 5.077. So I took negative 5.077 and raised it to the negative first power to flip it down to make it positive. I mean, just do this. What is 1 divided by negative 5.077?
I don't understand why we need to do that. Like why are
Because the original problem was 1 over this stuff. And if all I'm doing is plugging in that part, and I'm getting negative 5.077, I still have to put it 1 over that. There's a difference between this. What we figured out on our calculator was this. That's what we plugged in. But the problem is 1 over that amount. You don't get it. Yeah.
I think that's the answer. 1 over negative 5.
Okay, this is the answer, but that's the incorrect form. You can't have a fraction with a decimal in it. Does that make more sense? Okay, this is fine, but we need to simplify it further to write it like this. You either have a fraction with integers in the numerator, but you don't have a fraction with a decimal. Better? That makes more sense. Okay. Anybody else? What? You guys are all laughing at me. Why are y'all laughing at me?
I'm just laughing because I haven't seen your.
Y'all are laughing at